Hi everyone and welcome to another video. My name is Thijs, I'm the Technical Evangelist at Varnish Software. Today I'll explain how our partnership with Equinix allows you to have all the building blocks in terms of hardware, networking and caching software to build a private CDN and to improve your DevOps productivity and your security. Now I won't be talking about this alone. I'll bring on Charlie Lane, the Principal Solutions Architect at Equinix, to talk about this very topic. Before we do that, we need to talk some basics. So let's start at the beginning. What is a CDN? A CDN is nothing more than a collection of caching servers that are positioned in specific geographic locations where the audience is, where your users are. By storing a cached version of the content, users don't have to fetch it from the origin, which might be at the other end of the world. So by closing that distance, you're lowering network latency and improving performance and the all-around quality of experience for the end user. At the same time, we're also offloading pressure from the network because the network is separated and consumption happens from different pipes, but also from the origin infrastructure. The server is put under less pressure. In order to build and operate a CDN, either a public one or a private one, you'll need three distinct things. You'll need servers to run the workloads on. You need a network to interconnect systems and to provide access to the consumers. And you need caching software that powers the solution. For us, it's simple. We'll take care of the caching software. That's our world. And in the scope of this video, our friends at Equinix will handle both the hardware and the network. Let's talk about our caching software for a minute. Let's talk about Varnish Software. Varnish Software is a company that builds software-defined web acceleration and content delivery solutions. And when you peel back all the layers and bring it down to its essence, we in fact assume the role of a reverse caching proxy. That means we sit in front of the server, handle all the requests, and only talk to the server in case content is not yet stored in the cache or content has expired. This takes away a lot of the pressure, and one can consider this an origin shielding role. That's a big part of the story. We also have a built-in programming language, VCL, that allows you to tune the behavior of the cache to your exact needs. So rather than just serving content on the edge, as we call it, we can also compute content on the edge and qualify as edge compute technology. And regardless whether you're just delivering content on the edge or computing content of the edge, by spreading those caches geographically, putting them in key regions, you've actually built a CDN. So we can say that Varnish is content delivery software. We're not a CDN, we just provide the software. And because it is all software defined, you can host it wherever you want, on any type of on-prem commercial off-the-shelf hardware, or on virtualization platforms, in the cloud or in cloud-native platforms. Of course, because of our partnership with Equinix, Equinix will handle the hardware and the infrastructure. In this case, we'll be leveraging Equinix's Metal platform. Metal is single-tenant dedicated cloud hardware in an OpEx model. So you just press a button or do an API call and you spin up dedicated machines in specific geographic regions, all powered by Equinix's network. And last one of the basic topics I want to touch upon before diving into the discussion with Charlie is the question why you need a private CDN, because there's public CDNs that offer it as a service, you pay per gigabit and you're good to go. Well, for a lot of people that works, and for them I recommend that they use those public CDNs. However, for certain companies that model no longer works, and that's why they would go for a private and dedicated CDN. That means everything belongs to them, the network, the servers, and the way they run the software, which is very important from a security, but also from a data sovereignty point of view, which matters to a lot of companies. Also, because it's tailored to your exact needs, you can customize it, but also you have complete control and transparency. Other reasons why you would use a private CDN is cost cutting, reducing egress charges, not just as a complete replacement of an existing public CDN offering, but maybe also in a hybrid fashion where you mix and match. So that's where coverage comes into play as well. Maybe your private CDN is hosted in a specific location where public CDNs have no coverage or limited performance. Bringing it back to performance, because you tailor everything to your exact needs, you can also choose what type of hardware your private CDN runs on. So you have better performance, higher efficiency, and guaranteed cache capacity, which is not a commodity in this day and age. Now that we have our bases covered and you know what the context of this solution and this video is, let me introduce you to Charlie. Charlie Lane, Principal Solutions Architect at Equinix. Hi Charlie, thanks for joining me here today. How are you?
Yeah, doing great. Thanks, Thijs. How are you?
Well, I'm great. I'm great. And I'm happy that you're here because it gives our audience the opportunity to learn how we go to the market together, us as specialists in the content delivery and the web acceleration world, you guys being experts in connectivity, data centers, and infrastructure. Before we come together into a unified solution, maybe you should introduce Equinix to our audience.
Sure, thanks. Yeah, definitely happy to. You know, in many conversations, a lot of folks, when they say, "Who's Equinix? Aren't you the data center provider? Like data center? Why are we talking about cloud services? Or what are we doing at the NAB conference or Broadcast Asia?" I'm like, well, it's actually quite a bit more than just data center. Yes, we are known as the gold standard of data center services around the world. That's probably why people have heard of the name Equinix. But that's just our history. That's where we started. We started out with our data centers located around the world, and specifically centered around ecosystems. So we were the center hub for major ecosystems around the world, whether that be the financial markets or education. Education systems, colleges around the world, and many others, including now especially media and entertainment. And through these ecosystems, as we started to expand our metropolitan capacity in really key markets around the world, we became a very desirable destination for everyone to connect to these ecosystems. And because of this, as the kind of central location for all of this connectivity, in these different markets, we decided to expand that type of connectivity and create a layer 2 software-defined interconnection model across our high-speed, low-latency private backbone. And we created this thing called Equinix Fabric that enables service providers, 3,000 plus service providers, to present themselves on Fabric as a connection endpoint that anybody can connect to. This includes all of the CSPs. They saw that the internet, everybody that needs to connect, connects through these same hubs, these metros that we deployed our IBXs to. So they also deployed their core locations in the same IBXs and on ramp to the internet, often through Equinix. So we actually have the majority of native cloud on ramps in all of our global hubs. So this means that we have more native connections than the next 12 competitors out there. So if you want to get to Amazon, you're more than likely coming through Equinix. If you want to go to get to Google or Azure or Oracle, you're probably coming through Equinix. So so we are that easy on ramp.
It's kind of cool, but Equinix is I would call it an acronym, but it has a meaning, right? Because when we prepared this call, we actually discussed it. So can you explain what Equinix means and how this ties into that message?
Absolutely. Yeah, it's a really great point. Equinix, Equinix. It is an equal amount of neutral internet exchange. So equality, neutrality, internet exchange. So which that neutrality is really key here, right? The N in Equinix is really meaningful to us, because we partner with everyone. So we are a partner destination. So we're really a platform for platforms, to operate out of. So that neutrality means that they're the public clouds, they're both our customers and our biggest partners out there. So we want to make sure that that when our customers need to be able to get that connectivity, need to be able to on-ramp to these service providers, that we give them as much ability to do so, as much control, visibility, and performance as possible. Yeah.
And I like that very much because a wise man from the content delivery world once said, a CDN is 20% caching, 80% networking.
So absolutely.
Like from the perspective of building a private and dedicated CDN on top of Equinix, it's pretty apparent that networking is a huge part of it. But it's not the only part. There's the server, infrastructure, hosting aspect of it. To what extent are you guys involved in that?
Sure, absolutely. A really great point. That actually leads to the next several services that we've designed, deployed, and in some ways acquired over the last decade. So on top of the two things that we do incredibly well, data center space, highly available, highly reliable, and the best network in the world. we decided to create some additional digital services on top of that. Starting with a platform called Network Edge that rides on top of Fabric, where we provide the types of network-centric, network and security-centric deployment models where you can provision a network function virtualization, a virtual appliance of your preferred vendor, whether it be a next-gen firewall, a layer 3 router, a load balancer, SD-WAN appliance using your preferred, say, Cisco, Palo Alto, Juniper, Fortinet, F5, and many others, as we're on-ramping more and more all the time based on customer demand. So it means that the same types of tools that you want to deploy and provision to establish and utilize this this raw, powerful Fabric connectivity, we can onboard you and on-ramp you to the Fabric to connect to everything else in the world very easily.
But for a lot of users, this is pretty abstract. Honestly, when we were in the demo stages, and for all intents and purposes, we have a demo environment running on Equinix, for me, it was pretty abstract. It was like a black box. There is a network. It works really well. It's fast, but I didn't need it. And that type of networking, which is still really good, is called backend transfer. Is that the one?
Sure. Yeah. So backend transfer is actually a kind of a sub-service of ours that we provide kind of an instant connectivity, riding an Equinix Fabric backbone from one of our additional services that we provide called Equinix Metal. So when you look at Network Edge, we're taking care of everything concrete all the way up to the hypervisor, and then presenting you that specific vendor's platform. So if it's a next-gen firewall, then we're presenting you that firewall at that point. And we're taking care of that up to the hypervisor. But oftentimes, customers, they need more control. They need more performance. They want to have that virtual appliance take full advantage of the underlying infrastructure, which is really where Equinix Metal comes into play. So Equinix Metal.
And that's the part that I'm using. That's the function I'm using because I already mentioned in the intro, in order to run a solution, you need a network. I mentioned the quote, 80% networking, 20% caching, but the caching engine needs to run on something. And that's where, again, you are coming from more the lower tier, deep down networking and data center world. You're moving up the stack and actually offer yourself, what was the quote again? Single tenant dedicated hardware. You're in the cloud world. You're a cloud provider now.
Exactly. So in that instance, Equinix Metal is single tenant dedicated private cloud. So what we're talking about is bare metal provided to you as a service, so that you can build your own dedicated private cloud. So that means that you can provision your desired x86 or ARM servers so that you have choice on what you want to run on that physical infrastructure in the same way that you would from an on-prem perspective. And that's exactly what we did in our demo and pilot is as we provisioned directly on bare metal, and then with the single push button got essentially unlimited back-end transfer connectivity between multiple metros around the world.
And that's what I really enjoyed for this environment. We didn't have to sign contracts. We didn't have to ship servers. They're there. They're in an OpEx model. As you mentioned, we press the button. Of course, if you want to automate this, you'll use our APIs, which is a whole different story. So in the end, we've gotten the infrastructure bit out the way. So for us, it was easy because all of a sudden we had machines that were really well connected that we can run our software on. And for us, being software defined and being also very neutral where it runs, we were happy to have any type of Linux system where we could spin the systems up. Now, it's fun because it came in flavors. Of course, being a data center specialist, you guys could probably provide hardware that is highly customized to our needs, but we're fine with, we had some pretty decent servers, like 4 times 25 gigs, half a terabyte RAM. Those were our edge nodes. Those were pretty beefy boxes that could withstand a lot. Now, from our perspective, we can handle, as a software, 1.3 terabits per second on a single machine. This was benchmarked by Intel. Yeah, this is really powerful. So we're not really afraid of 100 gigs a second. That's It's a good start for us.
It's a good start. So, yeah, it's a good start. No, we actually had a pretty excellent performance, and that's on our standard on-demand available inventory, right? So we do, much like you would see from the public cloud side, from an on-demand hourly perspective, we have a publicly available pool of resources that you can provision with the t-shirt sizes as you mentioned. So and those are just available in. Those are available in all of our metros around the world. However, exactly to your point, it doesn't have to be those standards. The standard SKUs. We do have workload optimized configurations, and that's really what it comes down to. Is we want to be able to optimize the builds for your workloads. So we do have the ability to bring 100 gig down to the NIC. So get some much higher performance at the network layer, especially capabilities. So that tends to be more so under a reservation. Still, absolutely OpEx model, but we want to put that in a slightly different bucket. But all things are possible there, and that's just on the compute side. We also have the storage aspect where if you want to run high performance storage, tiered storage on that, then you can do so as a service on Metal using your kind of preferred flavor of partner ecosystems. Because again, we're neutral in this space. So whether it's going to be Pure Storage, NetApp, Vast, Dell Power Store, all of which are also available in the same way that we provision our compute. So
But from our perspective, that will be more the storage capabilities that you'll have on your origin systems, the ones that we're trying to offload, but it still makes sense to have a closer look at where you want to put that origin. You could put that one central point or like the source of truth in one data center and have everyone in the world pull it in. But of course, there's a little bit of inherent latency. So it's up to you to mix and match and maybe come to the conclusion that you'll need origin servers, application servers, web servers, storage in specific data centers, metros as you call them. Can you elaborate a bit on metros, what it means, where they are?
Sure, no, absolutely. So, so around the world, so Equinix Metal happens to sit in 31 metros. So really, when we could say metro, it's one metropolitan area. So that is one city location. So for instance, if we look at Ashburn, Virginia, Washington D.C. So that is the metro. It's the campus or metro connectivity with a multitude of different data centers. I think we're upwards of 22 data centers in DC. So when we talk about the metro, it's you're deployed or can be deployed across multiple data centers within that specific metro. But if you're going from DC to Silicon Valley to Singapore, to Amsterdam, then yes, you tend to have a little bit of latency. Speed of light is the speed of light. Can't really change that. However, what you can change is ensuring you have private, secure, and high performant connectivity, so that you have fully understood latency between those, so that you can make the right decisions about where you put your data.
So one of the things you said was it's private, it's dedicated. And I think that's one of the big topics here, why people would choose a private CDN over public CDN. In our case, as you've explained, everything's private. So you don't have any noisy neighbors. That's a good start. Also, there's complete security in there, because that's one of the big topics. It's in the title. Let's talk about that for a second. Like, how do you see security from a content delivery perspective from your side, the Equinix side?
Yeah, absolutely. And we have a lot of customers that that care very deeply about security. In which case, we are an excellent source of giving customers control, visibility, and access to the underlying infrastructure that they're provisioning. It is truly single tenant. When you provision that server into the customer's project, that is their server for the duration that it is running in the project, whether it's on demand or reservation. And from a reservation perspective, that is their server for the duration of their contract. So, and it is true single tenant infrastructure. And the connectivity as well is also wholly private. While yes, we provide all of the different capabilities to connect to the internet, you don't have to. So over that fabric connections, you can go from metro to metro across private dedicated infrastructure running across our dark fiber.
So that means that might be the good time to talk a bit about Fabric from a security perspective. Fabric is not just a network or the internet. It is a point-to-point connection, virtual point-to-point that is dedicated to you and that is in a sort of tunnel, if you will, that is entirely yours. Let's look at that for a second. So let's say I have an office and I want to connect to Metal and do some data transfer there over that pipe. How would we do that?
Absolutely. So when you think of Fabric, think of in a global sense. If you needed to go between your data center in one location, in Amsterdam, to another 20 data centers around the world, so that you can reach as close to your end users as possible. Now, imagine creating a full mesh topology from there to another across MPLS circuits. So that MPLS circuit gets pretty pretty crazy when you're looking at that many meshed connections. So that is Fabric. So we are creating a layer 2 software defined overlay across private MPLS circuits. So when you establish a point to multipoint or multipoint to multipoint connection, then you're doing so across private layer 2 connectivity.
And that could, from a use case point of view, that could be the origin having a dedicated line to the edges to feed that in with lowest of latency, highest of efficiency. Like from a solution point of view, how we present this in a private CDN perspective, it would make sense to choose your, I wouldn't call them battles because they're not battles, but choose your connectivity wisely and then make private connections using it as a service, right? That's what Fabric does.
Yep. So you're paying for two things and two things only, right? When you establish that connectivity, you're paying for the port, essentially the Fabric port, getting access onto the Fabric, and then you're paying for the virtual circuit, right? So VC. So that virtual circuit is just the size pipe that you need to be able to chuck your data down. We do have another product that we did fairly recently released called Fabric Cloud Router. This is enabling you to create a layer 3 topology over this and have BGP peering, especially for things like multi-cloud connectivity, going from on-prem to multiple clouds. This makes it quite easy. But everything we do is wholly automatable, right? It's API enabled, so you can run a Terraform script to provision all of this connectivity and your entire Equinix Metal ecosystem with whatever your preferred tools are. So if you want to run a Terraform script to provision this entire environment, maybe stand up a new site, determine whether that's a great location for distribution nodes, but you're not entirely sure on how much capacity you need. Awesome. Spin it up with Terraform script, do your evaluation at no risk or obligation.
And that's valuable to us as a provider of CDN services. You start off with the question you ask yourself is, we're building this private CDN either as a replacement for an existing CDN or as a sort of a hybrid approach to mix and match. You have your baseline of operations in specific metros, we'll use that terminology, where you know your clientele is. Well, yeah, establish it, build it out, and then it's up to you. You can use, like we use Terraform as well to spin up infrastructure as a service. We'll connect to your APIs, or at least the Terraform provider does that, and we can boot up a new metro because all of a sudden we see we're doing business there and users are consuming content. In that same hybrid approach, and that's where we move away from purely infrastructure and move into the networking side. We do not, as Varnish Software, have the arrogance to say that we'll replace all the big CDNs. That's just not the case. So thanks to the underlying network, you can choose a public CDN for the more bursty traffic, and your base of operations, your baseline will stay within Equinix, will stay on, for example, on Metal.
Absolutely, and that's a really great point. To go back to the N in Equinix, right? So we're absolutely neutral in this space. We live in a hybrid world, right? It is it's increasingly rare to find customers that are 100% in public cloud or 100% on-prem. Or more often than not, 100% in just one cloud, right? You may be in multiple clouds or a combination of both. So in the hybrid sense, that's where we lean on our neutrality and ensure that, wherever your workloads live, we want to make sure they operate best in that environment. So you have choice, right? There's choice. If you want to run your controller nodes in public cloud, and then bring your origin, bring your data to a cloud adjacent storage sense to enable it to be more utilized in multiple clouds to maybe decrease egress costs, maybe get more control over that data. Maybe you need additional security controls, visibility into that data. Maybe you need to replicate a huge amount of data to multiple sites around the world and need to get to a more performant and cost-effective manner. So that's definitely where we come in.
You mentioned the big one there, like the very sensitive topic, which is cloud egress cost. You can deploy our software on AWS, on Google, on Azure, on Oracle, on DigitalOcean. It doesn't matter to us. But for us, it's also looking at the reason why they're in the situation they're at. A lot of people go for the public cloud, and this is not me bashing it. Absolutely not, because the nearly infinite scale and the unrivaled and unparalleled automation tools they have in the cloud are just fantastic. So from a developer experience and spinning environments up, it's tough to compete with the cloud. But then, of course, from a cost perspective, we have to look at things. Things do come at a cost. People think the cloud is cheap. That's not the case. And again, that's not criticism. You get value for money, I would assume. But in the position we are, and you, Equinix, being the on-ramp to the cloud, there's ways around this, right? We see a lot of our clients who have our base applications with all the benefits they have from it in the cloud, maybe in AWS, maybe in Azure, and then use our edge solutions on other on-prem hardware. Well, on-prem is a bit of a contentious one, right? Because it's on-prem with you guys in your data centers, but you still offer it as a service. So
I think when you look at that, right? So it's all of the above, and more, right? So you're exactly right. There are partners, and we truly believe that workloads should live in where they are most effective, and meet the needs of customers. And we're not intending to compete with public clouds. No, not at all. We're trying to enable customers to utilize the services that operate in those public clouds the best in an as efficient manner as possible. So whether that's extending that cloud environment to Metal with say Amazon's EKS ECS Anywhere, absolutely, we're enabling that connectivity, or maybe Google Anthos on bare metal, to extend that that cloud connectivity, to provide that additional scale.
And the thing we need to learn as service providers or trusted advisors to our clientele is, even though we believe that some setups they have in the cloud are not the optimal ones, you threw in words like EKS, so Kubernetes is a big deal. We see that we need to be where the people are. You might have workloads that are not suited for Kubernetes, but the developer ecosystem is built around it. An entire army, if you will, of developers is accustomed to the workflow. It will be tough to convince them to go back to bare metal. So we just need to be where the people are. So if they decide to do that on those workloads, our software can run in Kubernetes itself, but it could be just as well on an edge right in front of it. So we need to respect those choices, and just to make sure that the way we on-ramp that is as efficient as possible. And we do that from our perspective with how we offer their software. You do that from your perspective with the way you connect. We make it seem as though everything we do here and everything we've discussed so far is for the benefit of the consumer and the end user. Now, of course, these CDNs that we built, we could call them private CDNs, but in fact, they're more dedicated CDNs. And the fact that they could be public, right? They could be public facing. And in a lot of cases, most of the content I create is, hey, here's how you build a CDN to serve your clientele. But if we go back to one of the core topics of this presentation, it's also DevOps optimization. We need to look inwards and truly talk about private CDN. It's a dedicated CDN for private purposes sometimes. And that's where the cloud and the interconnections come into play. There are a lot of workloads that live in the cloud that are there, maybe built artifacts, Docker images, building Debian packages, you name it. A lot of that software world, because everything's software these days, has systems where that lives on. In order to be efficient and to optimize those workflows, one could leverage a private CDN.
Without a doubt.
Let's focus on that. Let's zoom in on that. One of the approaches that I see a lot is people hosting huge Docker images because they have complicated requirements. They have engineering teams distributed globally, and they have data centers to run that, also spread geographically. Those are considered build artifacts for them, or runtime components, or even just, again, infra as code that they run on their local computer to develop features. We need to be in that space as well. And as of recently, we've identified that as a key solution, like private CDN for private purposes. So that's where I think Fabric could play a gigantic role.
Absolutely. I mean, the CDN space has been evolving. You know this better than anyone, being the experts in that field. It's not just about the traditional style of content, meaning that it's not just images or videos, right? It's objects, right? It's data objects that are useful across many industries, especially in the developer space now. And to your point, a lot of those objects are huge. They're massive and need to be accessible or made accessible to developers and other teams around the world in a much more efficient manner. Enter CDN into the space, and it is the perfect answer to helping solve for this kind of data migration process or a data evolution process.
Brings us back to the core values. What are we trying to solve? What are the reasons? You already said, like, it's private, it's dedicated. So from a security perspective, from a more of an internal governance or even regulations point of view, we have this covered. Now, before we go into cost, because egress cost, we already hinted towards it, we really need to get into it. I think one of the key things why people build CDNs within companies for large objects is developer efficiency. Developers cost a lot of money, let's face it, and making sure they work as fast as possible. I'm not sure if you've ever seen that XKCD comic where two guys are on chairs battling with swords and their manager asks, "What are you doing?" The answer was compiling. And I think the more modern version would be like, "I'm doing a Docker pull. It takes a long time. Let's have some fun because this could take a while." That is what we need to take away. That's what we need to optimize. So give me a use case here. I'll present the need. You present the solution from your perspective, Charlie. I'm a company that has maybe 3 or 4 groups of developers hosted in different parts of Europe, for example, because I'm European, and our Docker repository is hosted on Amazon, and we want this to be faster.
Yeah, absolutely. So starting with the source in Amazon, easy private connectivity to Amazon across a high-speed hosted direct connect. That direct connect can land on Equinix Fabric through an FCR, Fabric Cloud Router, to then be distributed over a private connection to the multi-sites within that region. So, that would then terminate on an Equinix Fabric port to the Metal side, where you can then provision and you can automatically provision your Varnish nodes to orchestrate your content environment.
What are the benefits of doing it that way? So you mentioned the Direct Connect, which is an Amazon product, going into Fabric Cloud Router, moving into Fabric connecting to Metal. So we have a whole range of services here. What are the benefits of doing so compared to just using the traditional internet? Sure,
absolutely. So the first benefit is across that private connection, you're not going to be egressing out the Amazon public side. So by default, you will have a lower egress cost from Amazon across the private connection. So if it starts, if that starts at say 10 cents per gig of data, that drops down to a fraction of that, at 2 cents per gig. So you're already going to see some cost savings across the private hosted connection instead. At that point, then you're writing the Equinix backbone. So you're on the Fabric at that point. In which case, there is no ingress cost. There is no egress cost. It's not a metered connection. So you're only paying for the port and the circuit at that point. So if once the content is arriving on Fabric or on Metal, then any of that additional distribution from Metal anywhere else, between those sites, across the private backbone, if it's going to a single location or all locations, then you're just paying for the port and the circuit. So it's all a private connection as well. So private connectivity, you have control over your bandwidth, you have visibility into your network to do your own tuning, and you can scale your infrastructure, in an automated manner, to accommodate, future growth in a much more cloud-like manner.
So we have the control aspect covered, we have the privacy aspect, the security aspect. Let's talk financials here. You already mentioned that egress is, what was your quote again? Egress is not your friend here. I heard you say that. That's definitely one, because that's the reason why people maybe host a Docker repository or other things like large packages. They could just do it over, let's say, Amazon or Azure or Google Cloud. Like from a performance perspective, it's great. I don't see any complaints, but it's the pricing, as you've hinted, that quickly starts adding up, especially if you do that at high scale. So you said you have a non-metered connection. We see great value, and we have a whole range of clients who focuses on that stuff right now, putting nodes in specific locations, caching them there, and like just a Docker pull or other Debian packager, if you will. It's just across HTTP. People are repurposing that HTTP protocol to make stuff happen, and it's very abstract. For us, we just put our layer in front of it, we cache it, we sync it, we drop latency. So from an efficiency point of view, the latency decreases. From an operational point of view, you have lower cost. But again, it's a matter of choice. You said some of that traffic will end up on the public internet, depending on how many. Let's say we go back to development offices or people working from home needing those Docker images. It doesn't make sense to have a dedicated pipe for every single one of them. So some of them will go over the public internet. Others, maybe there is an office where people go 2 or 3 times a week to work from in a specific region. Then it makes sense to do it over a private network and do it unmetered. But the choice goes beyond the network, right? The choice is also a matter of hardware. Like maybe you have one big development office where you'll put an actual server in a rack that doesn't use Metal but still uses Equinix Fabric, I'm assuming.
So that's that's the beauty of choice, right? In the hybrid world, you can have physical infrastructure connected on-prem. So and even if you're not an Equinix customer today, you can get on-ramped to the Fabric and start to utilize Equinix services very easily. That's one of the main functions of what Network Edge provides. So if you have remote offices that need to connect, you can do so with deploying a Network Edge, SD-WAN, and Node.
Having all these things in play, if we go to the cookbook of how we want to do it, well, we started with this use case of Docker images. Let's say we use Metal, so you spin up Metal. We'd use your Terraform provider there, or Ansible, or Chef, Puppet. Well, you come in different flavors, and then we spin up a couple of nodes in the key regions. Again, we have flexibility where we want to put the control plane because we offer 3 products. On the one hand, we have the caching engine, which is Varnish Enterprise. Then on the other end, we have the control plane, which is called Varnish Controller, that manages all these nodes and arranges the deployments of the VCL configurations, as we call them, for the sake of tuning the caching behavior. And we have the traffic router, which is the glue that ties it all together and that actually exposes itself over DNS over HTTP, ensuring that all these requests end up there. So again, it's a mix and match of where you going to host that. But once you start setting things up in Metal, again, t-shirt size matters. From our perspective, we'll take the RAM that you give us. So the flavor I'm running now has 0.5 terabyte of RAM, where we will allocate 80% of that solely to the Varnish D runtime process to make sure I wouldn't say we go line rate in terms of performance, but we're getting pretty close. CPU is... yeah, it's not really an issue, CPU, but we'll eat out those network cards. Like if you give us bandwidth over that network, we'll just eat all that traffic, and that's where we're focused. Now, of course, storage is also part of servers. I see that you offer NVMe SSDs on those systems, which are well appreciated for, again, the use cases where you go beyond the capacity of the RAM. 0.5 terabyte of RAM is pretty impressive. It's pretty nice. But maybe our catalog of services, maybe even a video collection can go into many, many gigabytes, maybe even terabytes. So we need a solution for that. What we do from our perspective is we use our massive storage engine, which is our proprietary storage component that lives on these disks. So we'd use the NVMe SSDs that you offer to extend that. Not in your traditional Linux format, use file system, open files, close files kind of way. Not at all. We would open a pre-allocated large file. Maybe if you have a terabyte of disk storage, we'll take that terabyte, open up one file, manage one file descriptor, read from one file, no directory iteration, and no disk fragmentation in that matter. So all of a sudden we have this really powerful thing where we have file system-like behavior on the inside. So whenever we're storing things that go beyond what fits in memory, we decide where it lives on the disk. You can have multiple disks, right? A lot of these flavors come with 2 disks. Again, t-shirt size, right? 1, 2 size NVMe spinning. And that way we can really, really make super fast long tail content. Of course, whatever is super popular will live in memory, as always. But even the long tail, you're not punished for it necessarily. So we do that in a super efficient way. Low memory copies, asynchronous direct I/O, file system-like behavior on the inside. And very importantly, we do not rely on the Linux kernel's page cache to choose what is being buffered from disk into memory. We wrote that ourselves. So all of a sudden, you're leveraging all that hardware, all that network capabilities to spin up these really powerful edge nodes. We also provide routers, just like you provide routers on a network level. We provide routers primarily on a layer 7 level, where we have an interesting trick for latency sensitive material like video, is instead of relying on DNS, Charlie, DNS has caching, can be annoying. So what we do is we provide an HTTP endpoint into that router where we'll request something and it'll do a 302 redirect to the place you want it to end up, which could be one of those edge nodes. So all of a sudden you need to think about the positioning of those routers as well. You want them in your key metros too, and we can equip them redundantly on those systems and make sure they don't need 100 gig network interfaces, these routers typically. They just need to be really fast, very low latency, and redirect either via HTTP or use that DNS. So all of a sudden, we've built up all of this momentum with the freedom and the choices we want to make in terms of network. We have hardware, either in the cloud, with you guys in Metal, in your colo cages, on-prem, all nicely connected. And then we install our controller software there and operate that.
One real big point I wanted to make is, I've seldom seen a partner such as yourself take true real advantage of the underlying hardware and use it as efficiently as I've seen in our pilots and our demos. I was incredibly impressed about the control that you took of the hardware and really pushed it really well. Used it very efficiently. So I was very impressed.
Yes, we try to get as much out of it as possible. And part of the paper that Intel made, so that 1.3 terabits per second, it was documented in a peer reviewable paper that was published by Intel. We can give you the bill of materials. You can build that stuff yourself. But the emphasis of it was, we will get the most out of the hardware as possible and at the least amount of latency.
Exactly. And that's exactly it, right? Is, we do have the ability to build out effectively whatever you need. So if that's exact bill of materials that you put together, if that's what you need, then at scale with Varnish, we can absolutely do that. I say often that our Equinix Metal network, especially when you look at the server to server, is very, very well engineered. In some cases, maybe even over engineered to provide raw unfettered performance. So which is really where you can get near line rate in this environment. So we're completely out of the way there and fully transparent. So I think the sky's the limit from a performance perspective. We can absolutely get you the 100 gig, the multi 100 gig to the NIC, and then connectivity outside. And east-west traffic server to server is really sky's the limit.
That's a great way to summarize it. So it's been made clear that Equinix, Charlie himself as well, as the principal solution architects, are experts in the networking, the data center business, and they also offer a cloud-alike product that offers single-tenant dedicated hardware that you can use to build out a private CDN. And we're taking full advantage of that in our demo environments. Demos we do to our clients about Varnish Enterprise are typically run on Equinix. We're very happy with that. So it's about flexibility, it's about performance, it's about making choices, it's about being neutral. And for us, while the topic is about optimizing security and DevOps efficiency, even for these private projects as public projects, we'll work every step along the way and highlight the pain points and tackle them. So us being software defined gives you tons of flexibility. It's clear that you guys have tons of flexibility as well, either in the cloud, on-prem, in your cages, anywhere else. So, ladies and gentlemen, thank you for watching this. I hope you see where value lies and how Equinix and ourselves as Varnish Software can go to the market together to help you out. If you're not sitting on top of your own hardware and you need an expert in that matter, we can provide a fully integrated solution that offers highly performant, highly customizable, dedicated, single-tenant private CDN. We just won the buzzword bingo.
There it is.
The only thing I could do here is to thank you, Charlie. Thank you for your time. Thank you for the effort. And thank you for tapping into all that expertise you have. We'll see you next time for more content, surely about private content delivery, but I'm pretty sure we'll make more content with Equinix as well.
Oh, absolutely.
Thanks for it.
Thanks, Thijs.